let us carry on some properties of the graphs. And here we'll focus on the path and connectedness. When we look at graph, let's see what is the graph trying to address. First, okay, we introduce three concepts. One is path problem, another one is connectedness problem, the last one is spanning tree problem. We will first talk about the first two, path problems and connectedness problem. First thing is the path finding. Okay, we want to find a path from one place to another. For example, we will look at the path from 1 to 8. So you can see the path length, if we choose this one, 1 to 2, 2 to 5, 5 to 9, 9 to 8, then the path length will be 20. But we know that that is not the only path. Okay, we can also choose another one, right? From 1 to 8, then we can go 1 to 4, 4 to 6, 6, 7, 5, 9, 8. It is another path that allows a node go to another node. For this case, it is 1 to 8. And the path length is different, and now it is 28. So it involves two different costs when you go to one place to another with different paths. There's another consideration that there's no path at all. For example, in this graph, there is no path between the node 2 to 9. So it comes to the concept of connected graph. Okay, so it is undirected graph, and there is a path every pair of vertices. Remember, we are talking about a path. It is not the edge. Okay, so give you an example. For this one, it is not connected because you can see, as mentioned previously, 2 cannot go to 9. Okay, there is no path at all, so it is not connected. How about this one? It is a connected one. Okay, it is connected because for every node 1 to 11, you can able to find at least one path from one to another. So that is the meaning of a connected graph. Okay, then we comes to another term which is called components. Components. So in this case, as mentioned previously for this graph, it is not a connected one. But if we look at these parts, these nodes and this node, okay, they can be said to be independent components. Okay, within a component, all the nodes are connected. So if we try to write it, it is a maximal subgraph that is connected, and you cannot add vertex or edge from the original graph and retain connectedness. A connected graph should have exactly one component. Okay, so that is the property of a component. Okay, so in other words, okay, as you know, it is a connected graph, as mentioned previously. So we cannot say it is a component. It is a component. No, it is wrong. So knowing this property, okay, then we can think about a communication network that, okay, we would like to every vertex are connected to others. So if you build a communication network, each edge is a link that can be constructed. Okay, we have to make it feasible so that everyone can communicate with another as long as there's a path. So when we're considering this problem, we will think about, is the network connected? Okay, that is, can we communicate between every pair of cities? Remember, it allows some intermediate node or vertices. And we will find the components if there are some nodes cannot communicate with each other. And want to construct smallest number of feasible links so that the result network is connected. So it is some sort of design problem. So how can we think about this problem? First of all, we would like to think about the cycles. Okay, as you can see that 1, 2, 5, 6, 4, it forms a cycle. Now remember, it's not a component, but a cycle. What that means? If it is a cycle, as long as we only remove one link between them, okay, we can still have those vertices connected. For example, for this one, if we just remove the link between 5 and 6, this 1, 2, 4, 5, 6 still connected by the other edges. Okay, so if we look at the whole graph here, if we move further, we can also remove the link between 1 and 2 and those between 6 and 11. Okay, there are other combinations, but it maintains the graph that it is still connected. So the connected subgraph with all the vertices and the minimum number of edges that has no cycle will be the one with the minimum communication links. In other words, we can reduce the cost, okay, for building the links between them. So it is one of the application when we talk about the identification of connectedness and the identification of cycles.